right, welcome everybody. I'm Lucian Fogoros. I'm the co-founder of IoT World. I want to thank you for joining. Thank you for the 5,800 or over 5,800 registered attendees that joined today from all over the world, from over 120 countries. This session is live, so actually all sessions are live. So please make it very interactive, and as a way to engage you folks, we are going to basically incentivize all folks to ask relevant questions. Put them in a Q&A, please. That is where we're going to invite everybody that asks those questions to our VIP community. So you save the $1,000. We're going to waive that fee to join the VIP community, and more details will be in a chat function. I want to take this opportunity to thank our speakers, thank our sponsors as well. Special thanks to the sponsor of this session, Siemens, for the financial support to make this available to you. And with that, I'd like to invite our moderator for the session, Mr. Jeff Winter of Microsoft, to take it on. The floor is yours. Thank you.
Hello, everyone, and thanks, Lucian. My name is Jeff Winter, and I'll be the moderator of today's session, which is how artificial intelligence and machine learning are transforming manufacturing. And I can honestly say that I'm quite excited about this session as these panelists are well known and respected in the industry. They have the talent, the technical knowledge, the industry knowledge, and years of experience to make them real experts. So I'm quite excited to hear what they have to say. And I'm also honored to be the moderator because artificial intelligence is a topic that fascinates and intrigues me personally. And that's mainly for two reasons. First is AI is extremely versatile in its application. It spans every industry and it impacts nearly every job function from entry level all the way up to the CEO. And second, AI just has this mysterious science fiction allure that captivates people's imaginations and curiosity. So this panel here today is going to help share their insights on how AI is specifically transforming manufacturing. So let's start by introducing our experts. So first we have Martin Cloak, who's joining us from Ottawa, Canada, and he is the founder and CEO of Raven AI. And Raven AI provides manufacturers with the complete and accurate contextual information that describes exactly how production time is spent. Martin is an experienced executive, engineer, and award-winning technology entrepreneur with a background in manufacturing. Next, we have Troy Wilson, and he's joining us from Paris, Illinois. And I'm curious how many actually knew there was a Paris, Illinois, but that's where he's joining us from. He is the team marketing and strategy manager for Siemens Cloud Solutions and has served 13 years with Siemens Digital Industries Software. He comes to us with a bachelor's in computer engineering and has spent the last 8 years working on cloud and IoT solutions. Next, we have Patrick Banger. He's joining us from San Jose, California. He is the vice president of AI at Samsung SDS, where his team builds AutoML software for others to make models and also builds models for many special use cases. His newest area of focus is AI modeling for medical devices in an effort to actually diagnose diseases from medical images, which is pretty cool. And last, we have Ryan Treese, who is joining us from Austin, Texas, where he is leading Tellet's business development efforts for their industrial IoT platform division. Their edge, cloud, and data visualization solutions enable the largest companies in the world to scale their AI solutions in a highly complex industrial ecosystem. So today, after kind of going through what we're going to talk about, we've kind of figured out that it's going to be three main topics that we're going to be talking about. The first one is kind of how AI fits into the larger Industry 4.0 and digital transformation arenas. Number two, we're going to talk about making AI successful. And third, we're going to talk about AI use cases today versus AI use cases tomorrow. So let's start the stage by asking the audience a poll question. Lucy, if you can bring it up, we have a poll that we're going to ask. Have you deployed an AI model? I don't know. I'm using it. I'm already implementing it. I'm evaluating. I'm planning, or there is no plans to adopt. And then when you think the numbers come in, Lucy, and we'll just let you share it. Oh, interesting. Quite a good mix across the board where everyone's at. So let's start on the topic of how AI fits into Industry 4.0. So one of the things that makes AI exciting, yet very difficult for people to grasp, especially when it comes to how to maximize the capability, is really the way that you think about AI. The idea of replicating human cognition has been discussed for thousands of years, and it's been sought after for many, many, many years. So because of that, it's not new, which means artificial intelligence isn't really a product. You could argue it's not really a technology. And it in itself isn't an invention either. There's no real day we can attribute to its beginning, and probably won't be, for its end. I would more describe it as a quest. It's a journey striving towards the goal of replicating human intelligence. It's constantly improving, expanding, and changing. But today, it's already starting to become everywhere. And it's mostly driven by advancements in other technologies, such as computing power and cost of computing resources, the internet, even down to sensors, and most definitely the development of machine learning algorithms. But what makes AI different than other technologies in Industry 4.0 is its ability to harness creativity and imagination, which means the sky's the limit on what it can do. But no matter how you look at it, AI starts with data. So that's how we'll kind of kick this off. So we'll start with Martin. You can't really take advantage of artificial intelligence or machine learning without data. So how does data quality really impact the use of AI?
Well, I think first off, the statement that you cannot apply AI without data is kind of, I think we all take that for granted. And I think there's sort of two data sources that we often miss when we think about what's needed to use AI properly in manufacturing. The first is the information and data that we use to even figure out what parts of our organization would benefit from this kind of technology. I think often the conversations about AI focus in on, the technical capability of identifying patterns within a niche application, but many manufacturers struggle to identify what part of their process actually needs this attention. So first is to make sure that data used to make those decisions about where to apply this kind of technology is complete, accurate, and trusted. And then once you've found the spot, whether or not it's vision systems or helping with planning or other applications, at least knowing that you are working on the right problem. The second point of data that is also important is that one of the promises of Industry 4.0 is interconnectivity. This idea that rather than optimizing a corner of your business, you are optimizing globally. And by definition, to do that, you need to draw data from across your organization. So if you're doing something with quality management software, or an AI vision system, to have the ability to draw data from your ERP and other systems is critical, because ultimately, we want to move away. The reason for IT/OT convergence is to move away from localized optimization to global optimization. And by definition, you need to be drawing from data from across your organization to do this. Now, once you are in the right spot, AI is an amazing tool to do stuff that we are not able to do ourselves, but it's still up to us to find that right spot of our organization that actually needs that kind of attention and investment.
Interesting, and I completely agree with that as well. So I'm curious, kind of now talking about continuing with the data aspect, where the data comes from. And so Ryan, knowing a good chunk of manufacturing data comes from PLCs, what challenges are there in accessing data off existing PLCs and scaling an AI system?
Yeah, great question, Jeff. I think it depends on how old or new the equipment is. Major challenges I'm seeing is on the legacy equipment. Some of them actually don't even have PLCs. So in that case, you're going to have to use some IoT sensors to gather that data. And the second major area we're seeing it is going to be across this complex landscape of different systems and industrial protocols. So having a global economy, depending where you may source your equipment, some may be talking one industrial protocol, and another machine next to it could be talking a completely different language. So tying those together with those IT systems, your SAP, your different large brands, and combining those, just accessing and commonizing that data has been a challenge for some customers out there.
And related to that, I guess to you, Troy, what other data sets or data and systems should you be collecting data from?
Yeah, so thanks, Jeff. I would argue that, I mean, there could be one, there could be many. We've already mentioned ERP, quality, MES. One that strikes out to me a lot of times is when people are embarking on this journey, which I very much agree it's a journey, is they think they can, they're starting brand new, but many companies already have a ton of data already sitting there in some legacy data historian. So that's a data set that's often forgot, that we need to actually be able to connect and collect that old data and be able to traverse it and give context, combining it with the new project. And when I say project, I mean, we need to also identify specific use cases in a specific KPI, because as you mentioned earlier, you don't just buy AI. It needs to be to a business value, it needs to be specific, and then you run it at scale. So whether that's vibration analysis for one machine or energy management at one plant, then you scale it across geographies. And that's that part of that AI that's also a non-product statement too, is there's a level of abstraction. So maybe you have AI at the edge for vibration analysis for several of your machines in one plant, but then you might want AI at the facility level or AI at the enterprise level, depending on what role you're at. So there's a context and there is an abstraction layer to AI to each little layer of the organization.
Interesting. Yeah, I like that. Now let's go broader a little bit. So for you, Patrick, how are you seeing AI work its way into the larger digital transformation strategy and kind of the vision and what we see for Industry 4.0?
Yeah, good question. So it starts with understanding what that digital transformation strategy is. For many people, it seems to be the same as digitization. Now, in my understanding, digitization is really going from the analog world to measuring these various quantities, throughput, speed, vibration, temperature, pressure, whatever, in numerical terms, and storing that in a database somewhere. That's digitization. It's a huge effort. It's very expensive because it involves physical equipment like sensors and cables and a little data center that receives all of this. But that is not the end of your journey. That is, fortunately or unfortunately, the beginning of the journey. Now that you have that data numerically available to you, you can do stuff with it. You can now decide on how you're going to access it. In many places that involves visualization software for the human being to look at it. And it's after that level that really artificial intelligence starts. AI needs data to be trained on, so you have to do that digitization first. And after you've made the AI, then you need to deploy it in a use case where it can achieve some sort of benefit. Typically speaking, it is the implementation of humans of that AI feedback that actually gives you the benefit. The AI itself is valueless unless you implement the AI result in a human process. So it's really the change management part at the end of that cycle that allows real humans to implement the results of the AI that is the value driver. And that in itself is also an investment in resources and time and so on. So it pays to keep in mind the full pipeline from getting a sensor in the field, the database storages, the AI modeling, the AI deployment, the change management for you to actually see real value at the end of the day. And keep all of that in your mind. That's Industry 4.0 for you.
So is it fair to say, and this could be really for anyone, that if you have this kind of journey towards realizing Industry 4.0, that you got to do a lot of stuff before you can take advantage of AI towards the end to kind of achieve the big vision?
Yes. It's a lot of steps, but not all of these steps are equally big. The digitization step is by far the largest, at least financially, because that's the only step that involves physical stuff. Everything else is completely digital that you can do with a few people. But it's important to keep in mind all the organizational steps you need to go through.
Hey, Jeff, I'll just tag on to that. It seems like we've all talked about connected shop floors or connected facilities and machines. AI is also applicable in a connected product too. So if you're going to deploy an OEM is going to go ship a product out, how your product performs in the field, and using AI to drive updates and or new iterations and revisions is also important, not just to the shop floor, but to the product as well.
If I can jump in here. So Patrick, one of the things you mentioned is that, you get value once people actually take action based on the insights uncovered from AI. Now, one of the consequences of the fact that, data fed into these systems isn't perfect, that sometimes the conclusion isn't perfect, right? So really the vision of Industry 4.0 is kind of a step on the way to 5.0, which is this idea that you combine what people do best with what technology does best. So I'm curious how you see people getting involved in that process of data collection and application of AI so that when the conclusion comes out, they're more ready to accept it and take action based on that.
Yeah, so of course data is imperfect, but whatever process you have in place today, which does not yet use AI, is also imperfect. So it's really just a question, is the AI system of the future more imperfect than whatever it is you have today? Probably not, right? So AI can, what we call gracefully degrade, which means it can deal relatively okay with worse and worse data quality, because it can take into account things like the uncertainty of physical measurements and thereby produce a result that has a plus or minus little delta gap to it, and then you can draw the right conclusions from that. So it's really quite stable. And even if sensors go offline or a sensor drifts, the AI can compensate or at least deal with that fact and still come up with a reasonable answer.
I guess the question was more from a people standpoint, because I saw an article from Google Research that said that 90% of AI models in this particular set of data had evidence of data cascades, which is basically errors in the data that caused the conclusion at the end to not be accurate. And then there's other report I saw from Accenture saying 70% of manufacturers don't trust their data to even make decisions. So I'm interested in sort of like your answer to that question from the perspective of people and gaining their trust, understanding that AI has capability to get the number almost there, but trust is something that is not logical. It's emotional, and at some point, if you've been burned once, you may not go back. So that's the challenge I'm most interested in understanding. Really, how do we gain that trust? And I know that Jeff, we're going to jump into this a bit later, but that's sort of how I was asking that question.
Yeah, I think just real quick, I know we're getting off it, but I think it's empirical, right? Put the model out there, have the users try it out, and they will only develop trust when they can touch and feel it and see that the outcome is correct or not.
I actually think it's a good segue to our next topic, which starts to transition into making AI successful. So let's kind of switch to that, and we'll put up our second poll, which is around how successful your AI model deployment is. And this one, so wait for it to come up. If you have not done one and you answered you're not doing one, then just don't answer the poll. But we've got very unsuccessful, mildly unsuccessful, it met expectations, slightly above, and way above expectations. Be curious to see what the results were here, because they were pretty even on the last poll. All right, 39% met expectations. That's great. That's great. And more, I guess if you add them up, about exceeding expectation versus not meeting them. So switching to successful AI adoption, why don't we start again with Martin? What's kind of the right sequence of projects to make AI adoption successful?
Well, I think I'll sort of start off by establishing, and maybe just repeating Patrick's line that I may do it again and again, but you get value from these technologies when people take action. And people take action when they're engaged and when they trust. And trust needs to be earned. So one of our challenges as we begin to apply AI in our organizations is that there's a bunch of different areas of our business that we can choose to apply it, and a bunch of parts of our business that happen to have messier data sets where the chances that mistakes are made in the initial model is higher. So I would say that you would, to gain trust of your organization, you need to be able to find areas that are most suitable for AI applications today. So I'll think, vision systems is one where it's something that people are familiar with, and it's something that we know is quite effective and better than what operators are able to do themselves, and it's intuitive. And I think that's one of the key things here, to find applications that are intuitive and provide clearly useful things to people on the shop floor, and then use that as the foundation to establish that AI can be useful. And I think, so to do that, it needs to be clearly useful and understandable. And I would actually start, with regards to data at lower levels of data in the IT OT stack. So sensor data, machine data, vision system data. As you move up into MES and into ERP, then those systems are much more complicated, where the chance that you have those bad data in there that may point you in the wrong direction is greater. So I would focus on things that are applications that are clearly useful and understandable by most. And then, to Patrick's point, show, the proof is in the pudding. Show people on the shop floor that it actually does deliver greater value than they'd be able to do themselves.
Great, I like that. Patrick, what are the major pitfalls in applying AI or ML to manufacturing, and how can you avoid them?
So I think the first is inadequate data literacy by the decision makers involved. That can be both upstairs and downstairs in the organization, whoever the stakeholders need to be. In the shop floor, it could be the shop floor people who say, okay, this fancy AI system is going to mess up my day. So I think educating everybody concerned on what data is, how is it going to be used, what is AI, and how's that going to deliver value, I think that's important. Most of the negative feedback I get is based on not understanding what we're trying to do or what this whole data science thing even is. The second thing would be change management. As I said before, this is based on that data literacy. Now you have to convince people that changing from the status quo to this new fancy AI methodology is actually beneficial. Beneficial to the company is something that's usually quite easy to tell people, but most people don't really care very much. The important part is, how is it useful and important to you, the individual human being in front of me? Is it going to benefit you personally, right? So worker safety, of course, is an important thing for people that are physically active, right? Is it going to keep you safer? Are you going to see your end of year bonus increase because the factory has gotten more productive? Is that a thing? If you're the manager, maybe. But change management, I think, is the principal hurdle here to convince people to be part of the new program, because it's better for them.
And those two make sense. This one is one that I'm sure a lot of opinions could be had on. I don't know if anyone else has an opinion they want to kind of add to this as well.
I wonder, just to add here, that the way that you would typically describe AI applications in an academic setting, or maybe at senior leadership, typically is top down. You establish the value, and then you add those layers of detail to support the reason for why you've decided to invest. That way of communicating often is difficult for different aspects of organizations to wrap their heads around, where having use cases and clear examples of success is often the easiest way to describe things to people on the shop floor. Taking that. So I think in some ways, for those of us who happen to think academically, we need to adapt our way of communicating the mission, which is what you're describing, Patrick, and adapting that to those on the shop floor, where they want to hear those stories, those things that they'll remember as examples of AI doing good things, like AI helping you navigate through traffic. Everybody can wrap their heads around that. Or AI picking out those emails that you don't want to get and sending them straight to your junk box. We need those examples that people can wrap their heads around. When you bring in a new technology, they already have AI on the side of useful things. Because right now, the way it's presented, it's coming up. It's this technology that's difficult to comprehend, combined with massive organizational change that nobody wants. And you take those two things together, and it's a disaster waiting to happen. So it's a challenge, but I think one of the things is how we tell the story to our organizations about what AI is. And often that story doesn't even need to have AI at the start of it.
I'll just offer the counterpoint. I always kind of look at that is also not what benefit did it give, but also what didn't happen today. So AI caused a machine to stop before the drive failed and somebody got hurt, or we turned off an escalator because the motor is going to fail before somebody has to fall down the escalator all the way down. So sometimes AI is good for what didn't happen and you never see it, but it's shutting things down or it's doing something different and nothing happened, and that's also good.
Or quality. Just think of the number of times where something went wrong on the quality side and you did not see it, right? And it's because you cannot inspect 100% of your parts. It's impossible. So you do 1%. So just the idea that you can actually stop these kinds of defects much sooner on in your process, or apply these models to come up with settings for your machines that actually stop you from losing all this part. This is super obvious. And I think I mentioned this before, obviously useful. We should be looking for obviously useful applications. And that's really what's going to help to get this to move quicker in manufacturing and in all organizations.
Hope we switch back on the screen. Lucian, if you can switch it back. Yeah, one thing that I would actually like to add to that as well, because I like that kind of analogy of talking about the use cases, is I always bring it back to kind of how electricity got successful. Electricity by itself didn't really take off immediately. It wasn't until devices came out that utilized electricity, like the washing machine, or something that then people were able to apply in their home, or the light bulb, or other devices that came out where it took off. And I absolutely agree, and we need that same story for artificial intelligence. So let's keep going here along this line of thoughts. So Troy, what areas or types of AI should you look at first? If you're just starting off, where should you look at first?
Yeah, that comes back to that use case piece of it. But I think depending on if you're going like connected shop floor, I mean, there's probably an evaluation on do I deploy some AI at the edge prior to doing any kind of AI across multiple enterprise data sets or other data historians. That's a good way to start looking at. Probably another thing to think about is when you're starting, make sure you have a defined platform. You don't want to get stuck in a place where you're doing, deploying one model for one line or for one factory. Make sure you have a platform that can both expand and take on the additional use cases that's going for that. That's where I would start looking at it. Is there a broad enough platform for where I'm going to deploy and manage my AI across my organization? That's right, the very first thing you could look at. And then do they have an ecosystem or is there partners involved that could help with some of the niche, vibration analysis or, any kind of temperature or pressure analysis? Because not everyone has data scientists and is able to make these kind of algorithms and analytics. So that's a way to look at it is look for a platform. That's what you got to define first.
Ryan, for you, so let's go from first to taking advantage of. So what's the best way to take advantage of artificial intelligence?
Yeah, great question, Jeff. I think it comes down to a few things. Once you have that executive top-down engagement, you make sure your data is all in one place and commonized. You need to engage with the people in each department and make sure that they have picked the correct problems that AI is able to be applied to. So combining that technical knowledge with the process knowledge, and then mixing in maybe some IoT instrumentation data to fill some of those gaps, to then automate once you have that result and understand which levers you're going to be pulling on the other side. So connecting that technical, the business system, and that process knowledge is really going to help drive a lot more efficiency and productivity for these installations.
I like that.
Thank you.
So let's do something a little fun here. I would like to do a panel debate lightning round. I actually want to have everyone have a chance to answer on this question, and then we can discuss it if we want, or debate as part of it. So we'll kind of go in an order. I'll call you guys out with it, but be short as you go through, and then we can talk about it. So what metrics would you use to evaluate the success of AI adoption or implementation? So we'll start with you, Ryan.
Yeah, I guess it would depend on the application, right? It's always, it depends as the start of the answers of these. But I think focusing on those results and then understanding the clear connectivity roadmap. So being able to look and say, okay, we have connected X amount of assets to tie into this system can be a portion. And then just focusing on the outcome of that, whatever business problem that they had stated previously, and seeing if there's a quantifiable metric to measure it by. So I think just looking at it from a pragmatic approach maybe would be the best way for that one.
All right, let's see what Patrick has to say.
I agree with that. It first of all depends, and secondly, I'd like to measure how often the AI model was actually used. So you can break that into stages, right? How often was the AI model executed? How often was the AI model's result taken into account? And how often was the thing that the AI model said to do actually done? And then what was the outcome of that, right? So it might be a more complex review process that you might do for a couple of months, but then you'll see that when you go all the way through to actually using it and tracking and tracing, you're going to get the best bang for your buck.
Okay, let's see what Martin's answer is.
I don't know if this is a metric, but I would say net promoter score for frontline operators. So if this were a consumer application, would they choose to long press, whatever you're using here and uninstall, or would they choose to keep it and tell their friends? So I would say that, measuring that as a engagement of the shop floor, and their support for the technology will be the predictor for whether or not it actually delivers value to the organization.
I like that you used a marketing metric to apply to frontline workers. All right, Troy.
I was going to give a similar answer. I mean, it's all well and good to prove out that, yeah, I can connect and get some data off of and run an analytic or a KPI. And that can be short term, but in the long term, it's all about the user adoption and how do you expand across the organization after that. So to me, success is being able to say, hey, it's adoption, we believe in it, and we're actually going to expand and move forward. It's relatively easy to connect systems up and get some data pulled into the cloud pretty easily. So that could be successful, but it's user adoption for sure.
Interesting. I was curious if anyone was really going to talk about the decisions that were made based off of the use of AI, and if that's part of a factor of evaluating success or not.
Sometimes it's good to be wrong because then you can fix it quicker.
Interesting. I like it. All right. So that'll wrap up topic 2. Let's switch to topic 3 then, and then we'll go to kind of the general Q&A for the session. So topic 3 is really about AI use cases today versus AI use cases tomorrow. But even with all the advancements that we've had in technology, we're still nowhere close to achieving the vision of artificial general intelligence. We've figured out computing and mastered it and wrangling big data, but we're still trying to figure out the learning and the intelligence components of this. And so therefore, most people actually describe AI as in its infancy. We're at the very beginning. And what that means is where and how we use AI today is definitely not how and where we're going to use AI tomorrow. So let's talk about the use cases. So Patrick, we'll start with you. What are the prime applications of AI and ML for manufacturing right now?
I definitely agree that it's in its infancy. So the prime applications today may not be those of tomorrow. Predictive maintenance is definitely the one that I see by far the most talk about. So forecasting at what point in the near future a certain piece of manufacturing machinery is going to break down. The second question is why? What's the cause for this? And the third question, what am I going to do about it? Do I need a specific spare part? Do I need a person with a specific skill set or piece of equipment to come out and fix it? You need those to, of course, plan the activity, and then, as Troy said, shut down the equipment prior to that bad event happening. The financial upside is obvious, and everybody's talking about that. The technical capability of actually fulfilling this is quite different, and that's why most people are still talking about this. And I see very, very few companies actually putting this in place, even though Every C-level executive has given a keynote on this by now, and at every conference, it's top of mind. A second prime example would be scrap detection for manufacturing, where I like to be careful to distinguish two parts of scrap detecting. One is your plant is making scrap, and all you really want to do is throw it away before you ship it to your customer. That's kind of the entry level into that arena, and AI can do a very good job of that. But the upper level stage is not even producing that scrap anymore by tracking and tracing where the scrap is being made, what causes it, and one by one eliminating the sources of scrap production. Again, by, of course, artificial intelligence, figuring that out, telling it to you, and telling you, for example, in advance when a piece of machinery is about to wear out and then start causing scrap in your production. Those are the two, I think, prime examples that I see.
I'd be curious from your side, Ryan, knowing that you have a background in IoT, and this would go for Troy as well, how you're seeing AI used in manufacturing today.
Yeah, a lot of what we're seeing is going to be similar to what Patrick had mentioned. We're seeing a big boost in the automotive industry, specifically for predictive maintenance. So they're combining that temperature vibration data on some high value assets with some additional process metrics to predict those failures. And then a lot of them are doing that one step further, and then once they're able to successfully predict those failures, they can place an order in their system for a routine maintenance tune-up, or even order a spare part from their chosen supplier in their purchasing system. So we're seeing a few different implementations of it for the predictive maintenance side. Another great use case is with AAM, and we actually published this one on YouTube. And they're able to look for productivity gaps in their process by applying AI to PLCs, robots, CNCs, and they can drill down to the individual motion when that machine is moving this slide or when that's moving this, and it's able to identify any kind of delays in communication or the next step. So a lot of different exciting AI use cases out there, from productivity gains, predictive maintenance, and of course the machine vision ones for quality are always fun.
And I'd be curious, go ahead, Troy.
Okay, yeah, I was gonna say, I can, certainly we're all talking about predictive maintenance, and that is the first and foremost on a lot of people's minds. I think an interesting one, those are all, like, people understand that, but then there's, like, you got to think about what other kinds of optimizations can I do in my facility that can directly affect my bottom line. And one of them is kind of like energy management. So we have one use case where it's like, how much energy does it cost me to make a part? And whether you want to be green or lean, or, hey, I just want to reduce my total power bill by 1% and I'll save, $1 million over the year. So you have to be able to analyze, what's the current draw on each machine, and can I optimize that in a way to, draw down my power and still have the same productivity. So that there's use cases, it's not just tied directly to the manufacturing of the part, scrap, or quality, but there's other use cases when you think outside that to the organization writ large, and other parts of the organization also. Where you have people are building circuit boards. Obviously the rate and the quantity is very high on a circuit board, but you have to go test real quick. Is the circuit good? Is the chip good? All these other tests. If you combine MES data with the quality data, with some of the design data, we found some companies that have said, you know what, that test passed 9 nines out of the time. We're not going to do that test anymore. We save 1 second per circuit board, and now my throughput goes all the way. We just remove the test. The AI said it's unnecessary. So it's an interesting, those are concepts that maybe are different than just the traditional uptime, downtime kind of thing.
I would agree with that. And I'd be curious if Martin has any that are more related to help building that trust right away that we were talking about earlier. What applications are you seeing today that we can use to build that trust?
Well, I think we're seeing a lot of the applications. I would agree, with predictive maintenance and quality system. But I think, one of the things, like the way that we're even speaking about these applications right now is highlighting how early we are in our journey. The fact that we are even just thinking about what parts of the business we could invest in to improve the bottom line. The fact that it isn't known what parts are the constraint for the profitability of our businesses is highlighting the fact that we are still sort of using our old methods of improving manufacturing, which is addressing one part of the business at a time. This stacked hierarchical model, which is what we wanted to get away from by doing IT/OT convergence. We wanted to pull it all together and have this one unified data source where we wouldn't need to start thinking about where we could. The AI can help us find out where we should. And I think that's one of the things that I am particularly excited about. The step before applying AI to these solutions, and I think with regards to building trust, and we're kind of repeating what we said in the past here, but it's having those use cases where people can see the value, and in some ways, I think Troy was mentioning the value in failing together. And I think the thing that we need to understand is that the way to make people more accepting of failure is to have them involved in the process early on. So if say shop floor are involved in figuring out where to apply the technology, and it's framed as early days in this journey, then they'll be more open to accepting the bumps in the curve early on, and they'll be more likely to provide the input needed for these solutions to be successful. So really, trust is earned. Trust comes from collaboration. I always think to those whiteboards on the shop floor that if you ever want to create some drama on LinkedIn, post something about a whiteboard, and then you'll have all the tech guys talking about why are you using whiteboards on the shop floor? But those are the operations folks, and then all the operations folks saying it works. So one of the things that the whiteboard does, it's not a really good way to present information, but it's that process of creation where people on the shop floor understood what was happening at every step in the way. And then you get to this end solution, which absolutely can be replaced with technology. So you can't quite do the same thing with AI, but you can involve people more early in the process so they begin to understand the kinds of things that AI can do that they can't do. And I think that's the key. Trust is earned, and trust will come with collaboration. And that's why I guess Industry 5.0 is so exciting, because there's this recognition that it can't be done with only AI. We don't need to wait for artificial general intelligence. It's fine as it is right now. We have tremendous capability, and AI can help us with the stuff that we're not particularly good at. But the team approach is one that will, at least in the foreseeable future, be much more successful than give us the black box that will give us the answer and we'll just do it. Like I don't see that being a successful strategy anytime soon.
I think that makes sense. Well, that's another good segue to let's talk about where it's going tomorrow, and let's do another one of those like panel lightning round debates. So we'll have everyone kind of answer the question of where do you see AI in 5 to 10 years from now? And we'll start with you, Troy.
Yeah. So I think that you'll see it much more deployed across multiple industries. I think some will be slower than others, or at least to be recognizable anyway. The other piece of that is you'll see a lot more. We have got connected products all the time. I see a lot more connected products coming out and driving that back into a enterprise solution and or a end user solution where AI is helping improve both the product consumption and the product manufacturing.
Okay, I like it. Martin.
Yeah, I think what is exciting to me is this idea that really to augment our capability. We often in manufacturing talk about the 7 wastes, which have to do with wasting resources and walking around too much and all that stuff. But there's, most people who talk about the 8th waste, which is wasted human capacity, by getting people to do things that are dull, dirty, dangerous. And I think this idea that we can unlock this human capacity with technology, in particular, problem-solving capacity by moving people away from these data processing tasks, it's going to unlock a tremendous amount of capability that we don't yet see here. And I think one of the things that's most exciting is this idea that right now we often think about how to optimize a process that's relatively static, but one of the benefits of unlocking this human ingenuity by unburdening people from these data tasks is that continuous improvement should go much quicker, and continuous improvement means continuous change. So having AI enable us to be much better at continuously managing change and following through on kind of the core principles of manufacturing established by Toyota and a long time ago, but actually enabling this with technology. So we had the phase where we were all lean, all manual. Now we have this digital phase, and this next phase is where we pull back the old stuff that worked with the new stuff that works to really achieve what the vision of what we're all trying to build together.
I like it. All right, Ryan.
Yeah, I think when I think of AI in 5 to 10 years, I really like the system integrator and machine builders are starting to apply it for their remote service work in the fields. I think keeping equipment running and making sure that there's less catastrophic failures through some remote AI monitoring and different models. I mean, it's a lot easier from a connectivity standpoint for these providers to just toss a gateway in their standard machine panel and serve up the metrics that their customers are looking for to implement into their customers' AI system. So I think we're going to see more use out of machine builders and system integrators to leverage their specialties and their product knowledge specific to their sector. And then they're also going to be able to tie it into larger AI-based systems at the customer base based off those metrics. So I think just the adoption rate is going to drive a lot more productivity and remote work and some reducing scrap. So I'm excited for those things.
Yeah, I like that. That's a different angle. All right, Patrick.
I agree with everything that's been said. I think it'll be adopted way more than it is today. And I think some of those successes, reduced cost, additional productivity, a safer working environment, less scrap, less wastefulness, all that's going to be realized. So I think, the value that AI can provide, I think is pretty obvious to everybody. It just now needs to be put into actual practice. And I think that's going to happen over the next 5 to 10 years. Part of what will be involved, I think, is that for most of the people involved, either the shop floor people or the management people, is that they will have access to numerous AI systems in their private lives, completely unrelated to manufacturing, but they will realize that, hey, AI is influencing my life multiple times a day. I'm sitting in a car that I'm no longer driving. I have access to healthcare where on the other side there is not a human doctor. I am talking to my phone, but there's not a person at the other end, right? I'm telling an AI assistant what meetings to book, what hotels and concert tickets to get, things like that. All of these applications are at the moment right on the cusp of being rolled out to the population at large. And so through that, people will become much more comfortable dealing with an AI system. And then why not do that at work as well?
Good point. I like that. Another angle. All right. So now let's switch to some audience Q&A before we wrap up. We've got quite a few. There's no way we're going to be able to get to all of them, at least in this live session, but we'll try and get back to all of them later. So let's start with this one. This is for anyone who wants to answer it. Do you see any relations between artificial intelligence and robotic process automation, RPA, to transform manufacturing processes?
All right. So of course there's a connection, but it's tenuous. So by and large, robotics is a separate field to artificial intelligence, and artificial intelligence has grown to be quite successful in the recent few years based on a few advances. Robotics, in the sense of influencing the physical world by grabbing things and moving things, is much behind because it's much more complex. it's ironically much easier to replicate the high-level mathematical thinking of a human being than the ability to grasp something. And that fact continues to be a big challenge for robotics.
All right. How would you convince that an AI solution would work?
Well, I think we kind of touched on that earlier, right? I mean, between the group, it was between, did we actually see real results from our pilot project? Certainly, I think the case has been that you don't want to start off and say, I'm just, excuse me, I'm going to deploy AI across my whole organization. You pick one use case and then you see if it's adopted. That's the keys and measures for success, unless somebody has a different opinion.
I think it goes back to your example there of the of electricity, or even at some point when you're mentioning that, thinking about the internet, really the topic of this 1990 would be, is the internet being used in manufacturing? And people will go like, what would I use the internet for? So in some ways, it's an application that has that result, and AI has its capability that can do things that we weren't able to do in the past. And the key thing is to have that practical result that somebody sees that's obviously useful, that you can actually create that little business case, and not a long, prolonged business case, a 2-slide business case saying, this is what we did, this is what we got, this is what we would have got without this capability. And I think there's a lot of opportunities for that. We just need to be thinking about it thinking about it within the frame of a business case. And I think, if you can make a clear business case that you can convince multiple people that is, makes a compelling case, I think that's a good frame to use to find those opportunities for early wins.
Okay. I like this question, and I feel like this is an interesting one. Will AI introduce false complacency? I'll get you to think.
I think it may, right? I think anytime you introduce a new technology to, especially something like manufacturing, there can be some misapplication of it. Machine vision comes to mind. I know for a while, a lot of manufacturers shied away from machine vision because it was kind of a catch-all problem solver. Okay, let's just throw a camera at it and then it'll fix it. I think really understanding what the AI was built for and what you're trying to do will help avoid that complacency. And by continuously monitoring whichever metrics you choose to evaluate that system, will help avoid some of that stuff.
What about using suggestions, I guess I would say, can you offer suggestions for great OCM, which I'm assuming is organizational change management processes, that you see best practices to make this successful?
I think it was Martin said it earlier. I totally agree that if you can get, it's not just C-level buy-in, but you have to get the whole team. All the stakeholders go from anywhere from the C-level to the plant manager to the supervisors to operators. You form a team and put some cadence of, here's how we're going to review things, here's the feedback we want. I think that's the way to go. You can't just thrust it upon them and say, hey, here's your new metrics, here's an anomaly detection system that we're going to use today. It won't work.
And there's complacency at all levels. I think recognizing that, the example that Ryan highlighted is a really important one, because, if presented incorrectly, operators at the shop floor could see this vision system as a threat to their livelihood and not recognize that it should open up new time for them to do more useful things. So if you present it in the wrong way, then of course they're going to say, okay, let the AI outperform me. And then if it doesn't do it, that they're in a bad spot. So I think now, in order for, we should also recognize that there's complacency at the executive level, which is probably even more toxic to organizations, where they simply see this purchase of technology as a way to add a few sentences to their quarterly letter and then clean their hands of it and then wait to see the results. There has to be commitment. Given the organizational changes needed, there has to be ongoing demonstrated commitment from leadership across the organization all the way to the shop floor to show that this is not just a fad, that this is truly changing how they're going to be running their operations and why it would benefit all. So there's complacency at all levels, which is really important thing to pay attention to during these, relatively significant changes that are coming.
I like it. Why don't we end at that note? I have very much enjoyed this conversation. I hope everyone else has, and I want to thank everyone for being here. I'll pass it over to Lucian.
Yeah, thanks, Jeff, and thank you all the speakers for the amazing insights and knowledge. So we have a lot of questions we have not answered. We are going to take that discussion via our blog and answer your questions. So appreciate you being very active. Also, at the end of the day, so we have several more sessions. Continue to stay here and get more insights. But at the end of the day, we'll have a drawing for 5 winners of Rebecca Morgan's book. So stay tuned for that. Huge thanks to you for sticking around. Huge thanks for the questions. I also want to special thanks to our sponsor, Siemens, for supporting us in this particular session. So with that, I'd like to invite you to the next session, which is protecting the endpoints in manufacturing. That's joining on, if you're in the attendance there in the browser, you can just stick around, the same thing, hit refresh. If not, please join the Zoom link, whichever one is best for you. This concludes this particular session. Thank you, Jeff, Troy, Martin, and Patrick, and Ryan for supporting us. Cheers.
Thanks, everyone.
Thank you. Thanks.
Thanks all.